Here's problem 3917. An electron, mass 9.11 times 10 to the minus 31 kilograms, has a speed of 0.5 c. Determine the difference between its relativistic kinetic energy and the kinetic energy calculated without considering relativity. Okay, well, let's see what our gamma is for this case. Gamma is going to be 1 over 1 minus 0.5 squared, square root. And that's going to be 1 over 0.75 square root, and that is equal to 1.155. So it's a fast speed, but it's half the speed of light, and it's relativistic, but it's not relativistic in the sense of really approaching the speed of light. So this is going to be interesting to see what this comes out to be. Now, considering the kinetic energy in a relativistic sense, that is the total energy of the electron, which is gamma times m naught c squared, the rest mass, minus the rest mass itself. So that's going to be equal to gamma minus 1 times the rest mass, mo c squared. So in this case, that's going to be 1.155 minus 1 times the rest mass of the electron, 9.11 times 10 to the minus 31, times c squared, 3 times 10 to the 8 squared, and this is equal to 1.2708 times 10 to the minus 14 joules. Alright, so that is the relativistic kinetic energy of this electron. What is the Galilean kinetic energy? The kinetic energy not considering relativity. Well, we know from Newtonian mechanics that would be 1/2 mass times velocity squared. In this case, that would be 1/2 the mass of the electron, 9.11 times 10 to the minus 31. And it's moving at a speed of 0.5 c, so the velocity squared will be 0.5 squared times the velocity of c squared. And that is equal to 1.0249 times 10 to the minus 14 joules. So the difference, the change in kinetic energy, the difference between kinetic energy of the relativistic approach minus the Galilean approach is equal to 1.2708 minus 1.0249 times 10 to the minus 14, and that's going to be equal to 2.46 times 10 to the minus 15 joules. So that is the difference in kinetic energy considering a relativistic approach as opposed to a Galilean approach. 2.46 times 10 to the minus 15 joules. If it were a macroscopic situation, it'd be hard to measure that, but if you were a high energy physicist, then that'd be something to consider and something you could measure.